Hi everyone, today we're going to be talking about topic 7.2, direction of reversible reactions. So in the last video I defined equilibrium, which is the rate when the forward reaction is equal to the reverse reaction. In other words, if I have N2O4 going to 2NO2 at equilibrium, these arrows are the same size. As in, I'm making as much NO2 as I am making N2O4. They're proceeding at the same time, at the same rate. When the rates are different between forward and reverse, they are explicitly not at equilibrium. So at any point in time, let's say I have that same reaction, N2O4 makes 2NO2, there could be a point in time in which the reverse reaction is much smaller than that forward reaction. And the way we represent it is with a smaller arrow, just like that. And so when they're not at the same rate, what that's basically saying is that they are not at equilibrium. In this case, the products are being made faster than the reactants. And we can investigate this in kind of the view of a particle diagram, right? A particle diagram tells you how many particles are in a particular reaction. And so let's focus on reaction system 1 right here. So in reaction system 1, at T equals 0, or the start of this reaction, we have 20 blue particles. At T1, this has progressed the reaction a little bit. We have 16 blue, and now we have 2 purple particles. If we look over at T2, we have 12 blue particles, and we have 4 purple particles. And so it seems in this case, our reaction is moving forward. At T3, if we count them, we can see we have, again, 4 purple particles, 4 purple, and 12 blue particles. What we see is that the forward reaction's increasing here, forward reaction's increasing there, but at this point, our reactions are equal. And so when we are in T2 or T3, these reactions are in equilibrium. In other words, the forward reaction is as fast as the backward reaction, and we're not making more purple than we are making blue. And so here, if we're going to represent this in terms of the 2 arrows I was showing before, in this, we essentially have a reaction that goes like that, right? We haven't gone in reverse. At T1, right, we're making a lot of forward and just a little bit of backward reaction. When we get to T2, that arrow is now at equilibrium. And again at T3. So as this reaction progresses, you're making more and more products, but at some point, the rate of going backwards is equal to the rate of going forwards, and you can see that there's no more particles. If we look over at reaction system 2 here, again, at T1, we have 20 blue particles, and we got no purple particles. If we look over at T1 over here, we have 16 blue particles, and we have 2 purple particles. If we look over at T2, we have 12 blue, and we have 4 purple. And finally, if we go to T3, we have 8 blue, and we have 6 purple. And so what we see is that this is increasing. This is increasing, it's increasing, it's increasing. And there's never a point in time where you have the same amount of blue and purple between 2 time trials. And so for this entire system, this entire reaction system, it is not at equilibrium, or it has not yet reached equilibrium. And I'll actually go back to this right over here. This first reaction, we should point out that these first 2 steps, we are not at equilibrium, because we're making more blue more purple than we are blue. Finally, let's go over to reaction system 3. Here, we have, again, 20 blue, 0 purple. If we look over at T1, we have 14 blue and 3 purple. If we look at T2, we have 8 blue and 6 purple. At T3, we also have 8 blue and 6 purple. So similar to the first reaction scheme here, at T2 and T3, we are at equilibrium. Even if, in this case, right, we're making the purples a lot faster, that doesn't really matter. At T2 and T3, we have the same amount of blue and purple, and so that means that we are at equilibrium, as in you're making purple at the same rate that you're making blue. So this here is not at equilibrium. So anytime you're looking at scenarios like these with phase diagrams, you need to see at which time point do we have a consistent amount or a constant amount of product being formed and a constant amount of reactant being formed. In this case, right, we have essentially blue going to purple. At equilibrium, we have the scenario where you're making as much blue purple as you're making blue from purple. So in the forward reaction, you make purple from blue. In the backwards reaction, you make blue from purple. We'll talk about this a little bit more in class, but for now, that's all. Thanks, guys.